Let's look at what happens to a wave as it goes between two substances by looking at what stays the same as it travels between our two substances. So I have two substances, one on the left, one on the right, one with an index refraction of 1.2 and the second one with an index refraction of 1.7. I have our wave equation, which says that the wave speed is equal to the wavelength times the frequency. Now if I look at my index of refraction equation and I rearrange it so that I know the velocity of the medium is equal to the speed of light in a vacuum divided by the index of refraction in that substance or in that medium. Using that as a guide, I know that speed of light is different between these two substances. That is, the average speed of light is different between these two substances. So the average speed of light is faster in the lower index of refraction substance. But you also got to remember that if we think about it, frequency is represented by color. So if I'm wearing a swimsuit and I jump into the pool or I get water on myself, the color doesn't change. It's still the same color. If it was red in the air, it's still red in the water. So the color stays the same, and remember that frequency is represented by color. So something else must be happening here. Because as it goes in, what's going to happen is the wavelength is actually going to change. Now I know all this because I know that frequency is represented by color. The color stays the same, so the energy is equal to HF. If the frequency stays the same, then the energy must stay the same because we know that energy is conserved. So that actually makes sense according to our law of conservation of energy. So energy is conserved and the color stays the same. If that's going to be true, then what's got to happen is the average speed has to change and the wavelength, which we can see in the diagram on the screen. So if we look at all this and we rearrange everything, we can see the index of refraction is equal to the wavelength in the vacuum divided by the wavelength in my substance. And I can see that what's important is as light travels from one boundary to another, its energy is conserved, therefore the frequency does not change, because frequency we can think of it as being represented by color, and color doesn't change. But the average speed of light changes and the wavelength in the substance changes in order to make sure that the frequency stays the same.